You can borrow a pencil. You can borrow one too. All right, here we go. Percentages. We're coming to the end of fractions, decimals, percentages. The last one is called percentage change. Interestingly enough, a lot of students struggle with this one at year 12 level because they change the wording. They usually call it percentage error, but in normal language, we normally say percentage change. And even then, students still get confused by it. And the basic idea is something like this. If I said in your pocket you have $1, and then for whatever reason, in the next 5 minutes, you now have $2. The question is, how much of a percentage change was that? Okay, this here is 100%. So most of you may have figured that out and got that logic straight off the bat. That's what's percentage change, because you went from $1 to $2, so that's a change. But instead of saying it's $1 increase, we say it's 100% increase. So we call that a percentage change. So that's the name. Why do we use percentage error in year 12? And why do students get confused by it? It's probably the language, not so much the mathematics behind it. Percentage error, because in real life, often we have a prediction and then reality. So we might predict that, say, for my year 12s, for example, I will guess that they could get a score between 0 and 50. At year 12, 50 is a perfect score. 30 is the average. So a student who's in the top 7% of the state is about a 40 and above. Okay, so if you're top 7% of the state, you get a 40. So say I predicted that they would get a 40, but they end up getting a 30, which they end up being an average. We can see that I have made an error in my prediction. How much of an error have I made? Not 10%, 10, because this is not percentage. This is just a score number. It's called a score. Later on in year 12, you guys will understand it's called a study score. It's just a number. That number is not a percentage. So how much am I off? I'm 10 points off. Okay, so 40 to 30, I am currently minus 10 points off, right? So the error is minus 10, but percentage-wise, how do we work out the percentage? How do we do that, Harrison?
Divide by the error.
Divide by the error. So what do you mean?
Like if it's minus 10%, sorry, if it's minus 10, and you look at the how much you could have got, and like divide it by that, and you times whatever what your error was by that, by the number you divide by.
Almost there. You got the general idea, and that's where a lot of students find it tricky at year 12. So when we say percentage error. But the technique of what Fraser did before to get 100% for this one is exactly the same as this one. Here's the formula. The formula was change. How much was the change? Divided by what you started off with, which we normally say the original amount. Now, we learnt from our previous exercises, if you want to change a proportion or a fraction to a percentage, what do you have to do again? Times, because remember, percent means every 100, yeah? So you need 100 of them. So to get 100 of them, you just got to times by 100. This is the formula for percentage error of percentage change, which is the formula for this exercise. So how did Fraser get 100% correct? Well, if you think about it, from $1 to $2, what was the change? $1. So it's $1. So 1 out of my original, how much did I start off with? 1. See, 2 is the future. This is the current. So it's 1 out of 1. So that's my proportion. But if I want to change that to a percentage, times by 100. So he was correct. If I times these two together, that's just 1 times 100. So he was right to say 100%. So then if I asked you for percentage error, which is what year 12 question is, even though it's the same technique. See, you told me I was 10 off, but I was minus 10. So if I use the same formula, it would be I'm minus 10 points off out of my original. How much did I start off with? 40, because that was the original prediction. So I predicted 40. This is my proportion. How do you change this to a percentage? Times 100. You just need 100 of them. Now, this is just, you can use a calculator at this point, or you can do it by hand. Obviously, in your test, your mastery test will not have any calculators, and you have to do it by hand. But here, which two numbers can we simplify? 40 and 100 is the better one. You could do 10 and 40, but these two are bigger numbers. So you want to reduce bigger numbers. What number goes into 40 and 100? 20? 20 goes to 100 how many times? 5. 20 goes into 40? 2. So this now becomes negative 10 over 2 times 5. But we also know that negative 10 over 2 means negative 10 divided by 2. What's negative 10 divided by 2? Negative 5 times 5. And using your integers from last term, negative 5 times 5 is? Negative 25. And this is your percent. So what is my percentage error? Meaning, how far off was I? I was 25% under or over, because they went below by 25% my guess. That's what it actually means. Yeah? So what we find, it's interesting that at year 12 level, when we call it percentage error, students don't know how to do this bit. But at year 8, when we call it percentage change, they can, even though the technique's the same. It's just the one formula. It's how much was the value of change over where you started? Because your starting point is what governs how much the change would be. So it's always the change out of what you started off with times by 100 because you got percentages. You need 100 of them. Okay? So today's lesson, that's all you're doing. If you're doing exercise 3J, if you're up to date and you're doing 3J, that's pretty much what all this is doing. So if you read the first example, this is question 6 of 3J. Here we go. Same idea. Gary buys a ticket to a concert for $90. Okay, so he buys a ticket. Here's a ticket. $90 is how much he bought it for. But then he can't go. He's unable to go for whatever reason. Also, it's Gary, is it? She sells it to her friend for $72 now. Sells it for $72. We are looking now for the percentage loss, because clearly they're not breaking even. They bought it for 90 and yet they're selling for 72. They're losing a certain amount. How much are they losing by selling it for $72, Lennox? Is it 28? 18, very good. So we are losing $18. Mathematically, we understand that, but usually we talk in terms of percentages, especially for businesses with big revenues and profits. We want to know what it is in terms of percentages. So yes, it's $18, but we want to convert this to a percentage. So how do we do it? Same thing as what we did before, the change over what your original amount was. The change was negative 18. How much did you start off with? 90. That was the amount that you spent. Minus 18 is how much you lost. This is a proportion or a fraction, but it's not a percentage. So how do I change to percentage again? Times by 100, because percent actually just means per 100. So I need 100 of them. So if I have 100 of these, it tells me in total how much of a loss I have in terms of percentage. So here we go. Let's multiply it together. It's negative 18 over 90 times 100 over 1. Let's see what we can simplify. What two numbers can you simplify? 90 and 100. What's the highest common factor, Osman? 10. Very good. So 10 goes into 99 times. 10 goes into 110 times. And we end up with negative 18 over 9 multiplied by 10. Conveniently, negative 18 over 9 reduces to? Very good. 2 over 1. Good. So it becomes negative 2. And so negative 2 times 10, what does that equal to? Negative 20. Don't forget the percent symbol. So if we asked ourselves, how much of a loss in terms of percentage did Gary lose, we would say she made a 20% loss by selling it for $72. Does that make sense? Okay, so usually we would say made a loss of $18, but when you have a business or you have multiple revenues from different products that you sell, it's less important about the dollar, but it's more important about the holistic percentage. We like percentages. That's the benefit of it. Yeah. So that's all you're really doing. It's just change. So how much was the change over what's the original? You always times by 100 to convert it to percentages. Okay. Let's try the next example. You try it yourself first, and then we'll check if you get the correct answers. I'm going to pause the video. Here we go. 3, 2, 1. We're going to one, and here are the answers. Can I get a show of hands who got 650% or at least was on the way to getting 650%? Hands up. Okay, because the main skill is not that it's the theory. I'm pretty sure most of you understood the theory. It's whether you can do this bit. This bit is part of 3B. The stronger your times tables, the stronger your factors, the more likely you can do this bit. Okay, so with a calculator, you can definitely do it. It's just more if you can train to simplify large numbers. Okay, so that will, each and every one of you will be slightly different on that skill. Okay? They're just the times table skills. There's nothing that you can't do percentages. It's totally irrelevant. It's literally about practicing multiples and factors. All right, Tim, I'm going to stop the video.